Hello once again, our most valued student. My name is Confident and welcome to the sketching of graphs, and this is an introduction if ever you want to understand the basics behind the sketching of straight line graphs. So now this would be suitable for you, those of you who are doing your grade 9, and it will lay a very important foundation for your future mathematics. So this is the sketching of graphs. You can start it from grade 8, but grade 9s are the most relevant students for this lesson. Now, what does it entail whenever we're talking about sketching of graphs? Now, what we're going to do before that, this is what I want to go through. These are the graphs that I want you to sketch, as you can see them from A up to E. So I just want you to stay tuned so that you can see how they can bring these different graphs in the exam and how you can approach them. What is important is not the actual graphs, but how you approach those graphs. Okay, so let's start by looking in general at what I refer to as the Cartesian plane. So let us draw the axis for the Cartesian plane. Let us suppose you are given this and you are given that. Oh, you're not given, actually, you draw. So whenever you are drawing the Cartesian plane, you will have two axes, which we call the vertical one, we call it the y-axis. See this? And the horizontal one is called the x-axis. Very important. So you need to label it whenever you are sketching a graph. You need to show us that in as much as it is known, but you need to show us with an arrow that going up is the x-axis and going horizontal is the going up is the y-axis and horizontally is the x-axis. So the y-axis, what we are saying is, how do you recognize them? These are vertical. This is what we mean by saying this is vertical, and these are horizontal. Okay, now something is also important. Now this is just not necessary for me to write, but there's something important I want you to take note of when it comes to the axis. It is the positive side and the negative side. Now what I want you to remember is that when you are moving this direction, as you can see, the arrow is going that direction, which is from what? From left to right. So this is the direction to right. Okay, we are saying you are moving in the positive direction. This is positive. And then we have a division line, or we have an origin in that center there. Everything is happening in that center. We call that part 0 or 0 for origin. Is the origin, that the starting point. So from the origin going to the right, we are saying it is positive. Again, from the origin going up like this, you see, vertically, it is also what? It is also positive. But don't forget, you must always start from the origin. And then the opposite is true. From the origin going to the left, it is what? It is negative. Alright. And then from the origin going down, you are also looking at something that is negative. It's more like in real life, when we are saying you are going down, things are going down, we are saying it's a negative circumstances. When things are going up, it's linked with positive. When things are going right, it's linked with positive, but when things are going to the left, it's sometimes linked with negative. So it's more like that. So this is very important in your Cartesian plane. The second thing about the Cartesian plane is, whenever you are dividing it, you must be uniform. What am I trying to say? Let's say, for example, you want to mark your Cartesian plane, and we want to mark for every box like that, and like that, and like that. You see, I'm jumping for each and every line, it's uniformly a box that I'm jumping. So it must be uniform. Similarly, if you choose to jump 2 boxes, you must be uniform. You jump 2, you jump 2, you jump 2, you jump 2. See what I'm doing? You cannot jump 2 at one time and then 1 at one time. You must be very consistent. You must be consistent. There is nothing like very consistent. You just have to be consistent. So even on the negative side, you see, I'm maintaining a box. So for example, if this was me doing the markings, so I would have said that is now 0 there. Remember the origin. Then this is 1, this is 2, this is 3, 4, 5, 6, 7. It's positive, remember. Then on the other side, I have -1. It's like a number line, remember. -2, -3, -4, -5. Remember, 0 is the one that is at the midpoint, the origin. And then when I'm going up, avoid writing this side. We don't write this side. We write on the left hand side of the line. So here we said it is positive. I don't have space to write. If I'm to write, maybe I can choose to start. Remember, depending on your scale, I can maybe use a scale to say this is 2 and then this is 4, or it might be that it requires me to use a scale of 5. Then this would be 5, this would be 10, positive, and then going down is -5 and it's -10. Anything, but you need to be consistent. So this is what we call a Cartesian plane. All right, when you have a Cartesian plane, as we're talking like this, we had a question here which needed to sketch this graph. So at the end of the day, I want us to have an idea on how do we go about sketching these graphs. So the first one that I want to show you is this one. How do you sketch the graphs of y is equal to 4, x is equal to 4. So now here, first of all, have your Cartesian plane ready. So you draw the Cartesian plane, usually in the center. I draw the Cartesian plane like that. Remember, you need to show the arrows. You need to show the arrows, and then you need to label. This is the y-axis, and this is the x-axis. Alright, when you have done that, then you need to do your markings. Now they wanted us to mark for x is equal to 4, y is equal to 4. As I said, it's up to you how you want to divide it, but you can divide it constantly to say this can be like where 1, my 2, my 3, my 4, my 5, my 6, you see. Then -1, -2, -3, -4, -5. You know, you don't have to go that far. Then this can be also like a 1, 2, and 3, and 4. I don't have any space more. And the 1, -2, -3, -4, -5. So when I write, this will be 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 6. Again, 1, 2, 3, 4. See, then 1, 2, 3, 4, 5. Now let's come back to the actual part. We said the right is positive and the up is positive. The left is what? Is negative. Then you put the negative, 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 negative. Down again is negative. You do that. So these are very important. So now you have your Cartesian plane. From here, you go now to say we start sketching. They want us to sketch and compare the graph of y is equal to 4, x is equal to 4. So you come back and say, okay, now where is the y-axis? You come then and say the y-axis, you can see them, the vertical one, and then, oh, before I forget, what did you say? The origin is 0. Very important also to mark that origin as 0. Very important, please. It's just that there is no like an actual space to write it, but it's very important to put that 0. So let's go back to the question. Y is equal to 4. As you can you see, it says the y must be equal to 4. Now as I was plotting the graph, plotting the points, this when I was having 1, it was y is equal to 1. Here it was y is equal to 2. You see what I'm doing? Here it's y is equal to 1, y is equal to 2, y is equal to 3, y is equal to 4. And then here x is equal to 1, x is equal to 2, x is equal to 3, x is equal to 4. Why? Because I'm in the x-axis. So when I'm in the x-axis, these are the x values that I'm dealing with. You understand that? So if you say to me, I sketch a y is equal to 4, guys, it's not complicated. You take your ruler, you go where it's 4, you have a line that is horizontal like this, which must cut at 4. Then that graph is y is equal to 4. And then you do the same thing when they say sketch a graph of x is equal to what? X is equal to 4. You do the same thing. You go to where x is equal to 4 on the x-axis, and then you draw a graph like that. This is a graph. It's just vertical like that. And that graph is called x is equal to 4. So that's why they say compare the two graphs. So this y is equal to 4, it's what? It's horizontal. See? So just be careful. This is where now sometimes it confuses students. The y-axis are vertical, but the graph you draw of y is equal to 4 is horizontal. Same thing with the x-axis. The x-axis are horizontal, as we said, the x-axis, but the graph you're going to draw is vertical. It's cut at x is equal to 4. If they say draw a graph of x is equal to minus 6, you do the same. You come where it says minus 6, and then you draw the graph. There it is. This is x is equal to minus 6. This is x is equal to minus 3. See this? So if I can say this graph, you'll be saying x is equal to here minus 6. On this one, it will be x is equal to minus 3. If I give you a graph like this and say sketch this graph, and then this graph goes like that, you ask yourself, where is it cutting? It is cutting the y-axis. And where is it cutting the y-axis? At -4. So you're going to say y, because it's cutting the y-axis, is equal to minus 4. So this was just the extra info. Let me take it out. I was giving to you just to remain with what I have. Now let's go and look at the other graph. They are saying number B, we are supposed, or we need to sketch and compare the graph of y is equal to x and x is equal to y is equal to minus x. All right, and I've been telling you of the what? Of the Cartesian plane, because the Cartesian plane is very, very important. So if we are to have for example, your new Cartesian plane, let me make it a bit smaller. And then, okay, now just before the Cartesian plane, this is now what I will say to you whenever you're drawing the graphs. Let's come back to this. They are saying you need to draw the graph of y is equal to x, and you need to draw the graph of y is equal to negative x. Now pay attention. When you're drawing these graphs, there are two ways you can do. We have what we call the table method, right? So what you're going to do, you're going to draw a table for each graph like this, and this table is the one that will give us the x values and the y values. You can determine the x values, or they can tell you which ones are the x values, and then you need to do the y values. Remember, you did the input and the output. So this is exactly what is happening. The input here, in this case, these are called the input values. These are the input, and then these are called the output, what you get out. Okay, so in the input values, you always have your x, and then here you always have your y. So it's up to you. In this case, since they just say sketch, you can tell us where do you want your x to start, but be careful, always have the negative and the positive together, because this is what we call a straight line graph. You must have a part of the negative. For example, let me start from -3. I just chose that. From -3, remember you start from the bigger number that is negative. And then from 3, remember it's 2, it's 1, it's 0. You just have to put minus, minus. And then after 0, remember the point of origin. You have got 1, you have got 2, you have got 3. I still have another space. I can go for 4. Right. Then you need to tell us what is the value of y when x is -3. So that's what you say. You are starting with this first graph to say, what is the first graph? It is y is equal to x. The good thing is, whatever you make x, that is equal to y. So when x is equal to, when you take this value there and you say x is equal to -3, look at y. Y is also -3 because x is whatever y is. Are you seeing that? I repeat again, x is whatever the value of y is. So when x is -2, because x is equal to y, y is also -2. When x is -1, for example, if I say here x is equal to -1, then I'll say y is equal to x, but what is x? Which is -1, which is equal to -1. So you can say that y is also equal to what? Y is also equal to -1. So it's easier then to write the values. When x is -3, y is -3. X is -2, y is -2. Even here -1, and so on. 1, 2, 3, and 4. That is the first part of y is equal to x. This is the table values. Then the next one is the graph of y is equal to -x. So let us have a look at that one. You do the same thing. So since we're going to be drawing it on the same graph, we have to now maintain our input values. That is very important now. Since we started with x is equal to -3, it will be good to maintain our input values so that they match, so that our graph in a way have a way of standardizing or matching the axis. So here it's always your what? It's always your x, and this is always your y. We said input, you tell us where you want your x to start from. -2, -1, 0, 1, 2, 3, 4. This is what you tell us. Sometimes in science they call the x values like that the independent the independent variable. Why? Because it's the one that you are changing. It's the one that does not depend. Actually what I'm trying to say, if it's independent, means it's the one that is changing, and y becomes the dependent, meaning what does y depend? Y depend on whatever value of x you're going to choose. You see, when x changes, y follows suit. That's why y is called the dependent variable. So you come here and say, okay, this was the graph, and we had said the one that we're having here is this graph of y is equal to, I just need everything here. It is the graph of y is equal to what? -x. Now, from here, look at this. We are saying y is equal to -x. But what if x is now -3? See what I'm doing? So you're going to say y is equal to negative from that. Then from here, you put a bracket to say -3. Because why? There is the negative of the equation that is already given, and then we have got x being negative. So these two negatives now means y is equal to +4. You can do the same thing with 2. If y is equal to -2, it will be -2. Minus multiplying gives you a positive, then you get a 2. But look at this one. When x is equal to, for example, 2, you are going to say y is equal to -x, but x is 2, y is equal to -2. Are you seeing that? So that's what you just need to be aware of, to say these values, when you are doing them, you need to be careful the substitution. So here you see -3, it's just a matter of changing. I don't know why I said 4 here. It's negative 3 here. It can't be a 4. It's negative 3, which is positive 3. So here we have got a positive 3, and then here we have got a positive 2. Same thing with 1. Minus 1 is positive 1. 0 is simple. When you say y is 0, when you come and put a 0 there, minus 0, you say 0 doesn't have a sign, so you just put a 0. When we said here, when it was 2, you got a negative 2, meaning 1, you'll get a negative 1. 3, you'll get a negative 3. 4, you'll get a negative 4. Are you with me? Now, this is you using the table method, but there is also another way I can encourage you to go for. We call it the calculator table method. You come here and you go to number 3, which say table. See that? Then it will say f of x. Some calculators will do two things. It will have f of x, and as you continue, you'll see g of x. So you can do both. But let's start with this one for f of x. So what are you saying? The f of x here is the y. That's what it means. When you're saying f of x equal to, we are saying y is equal to. So the thing is, it says y is equal to x. So we want to plot this part which says y is equal to x. So you say y is equal to, you press alpha, then if you look down there, you can see there is x, y, m. So you go for that x. Then you say equal to. Then it says start. Where do you want to start? From the first table, we said we want to start from minus 3. So you also say minus 3, you say equal to. And then they ask you, where do you want to end? You said you want to end at 4, from minus 3 to 4. These are the x values. You also put 4 equal to. Then it's asking you about the steps. What steps do you want to take? The steps is from one x value to the next x value. What is the difference? It's 1. Remember, it's, for example, 0. From 0 it's 1. From 1 is 2. So it's one step after the other. If I was using 5, 10, 15, 20, I'll say it's a step of 5. If I'm using 10, 20, 30, 40, it's a step of 10. So the steps is from one x value to the other. What is the difference? From 0 to 1, the difference is 1. From 1 to 2, the difference is 1. From 2 to 3, the difference is 1. So the step here, you maintain it as 1. You say equal to. Then you will get this kind of table. Look at this. Remember, f of x stands for y. The x values, you see, minus 3, minus 2, minus 1 are the ones that I told the calculator to have them. They will go all the way to to 4. From minus 3 to 4. Now look at the y values. Minus 3, what is y? Y is minus 3. That's what we also got. Minus 2, y is minus 2. Minus 1, y is minus 1. You see, it maintains the same value. So that is another way of doing it. If I wanted to do the other graph, y is minus x, now I would do this to say f of x. Remember, I'm in table 3. F of x is equal to alpha. Before alpha, it's first minus. Let me remove that. It's minus because I want to plot minus x. Minus, then alpha, then I look for that x. You see, very important to put that negative. You say equal to. Some calculators, then that's where they have g of x. So since you are starting now, you can ignore g of x. You just say equal to, so that nothing comes into g of x. If you know your way, you will say actually you can have two graphs, f of x and g of x, meaning the other one can be y is equal to x, the other one will be y is equal to minus x. So minus x becomes g of x. So your calculator will be able to do two graphs in one. But for the sake of starting, when it says g of x, just press equal to, meaning you are ignoring the g of x. Okay, so where are we starting? We said we start from minus 3 equal to. Where are we ending? We're going to end at 4 equal to. Our step again is still 1 equal to. Then look at it. When x is minus 3, what is y? Y is 3. You see, it's positive. When x is minus 2, y is 2. When x is minus 1. So you can use this to verify that you're doing the right thing. Later, when you're doing your grade 10, 11, 12, you'll be just quickly using this because the table method is going to fall away. The table method here is just to help you know how these graphs come about. Alright, so this helps you to come up or to verify that you did the right points. If you see that you put this on the calculator but you're getting something different, it's either you check if you did right with the calculator or you check that you're doing right with your calculations. Alright, so that's what you do with the calculator to assist you in the sketching of these graphs. Once you have your table method, then you're good to go. We can now plot the graph. So let's come with this part here. So this, you still have our points, and now let's try to sketch the graph here. Okay, this is our y-axis, right? And then try the center. This is our x-axis. So you do that and you do that to say this is my y and this is my x. And then you remember to say where is x starting? X is from -3 to 4. It will help you to know your division. So we can do like what we did previously. We move by a unit of 1. Say this is 1, this is 2, this is 3, this is 4. It's still allowed. Or if we see that we got enough space, we can actually jump 2 to say this is 1, this is 2. So every 2 spaces I'm jumping. This is 3, this is 4. I'm allowed to do that. So look at this. This is 1, this is 2, this is 3, and this is 4. Now if I'm writing, this will be 1, 2, 3, 4. It means when I continue, this was going to be 5. You see that? This will be my -1, my -2, my -3, my -4. Again, with the y-axis, up to me what I choose. I can choose to make it like this. This can be like this. I can choose to make it a 1. This one can be 2. This one can be 3. This one can be 4, because I don't have much space going up, you see. So you can choose just one box. -1, -2, -3, -4. Then how do you mark your points? That's where now we are learning. How do you mark your points? For example, go back to the first one, y is equal to x. We're here now. So we are saying when x is -3, y is -3. Where do we get that point? You come here and say, okay, I'm going to go to -3 for x. Remember x-axis, there is -3 here. So you're like, oh, I'm here, -3. That is for x. That's x is -3. Remember, x is -1, x is -2, x is -3, and it said y was -3. There is y is -3. So what are you doing? You are going to be looking at, in a way, you are going to hold your hand down here to -3, and you hold your hand of y to -3. Your hand is going to meet somewhere there. That's the point you're going to mark. Are you with me? So what you do, you come here and say, okay, I saw my point. Let me mark it. -3 is going to meet there. You do the same thing when x is -2, y is -2. Remember, this way easier. When x is -1, 0, 0, 1, 1, 2, 2. So I'm just going to plot it as I'm looking at it like that. I'm not going to refer to the table. Look, if you're looking at -2, you're going to say, okay, there, take your hand, go down with -2 at the same time, go down with -2 for y. Do you see where your hand is going to meet? Your hand is going to meet there. Do you see what I'm talking about? So that is how you are plotting these points. So I can take this off, I can take this off. There is the point. When it's -1 and -1 is the same thing. I can have my hand going through -1 like this, and my other hand must go through -1, and that point where they meet here, that point is the point of which I must I must sketch. Here I'm just removing that because it won't make any neat sense. Are you with me? So we do the same thing when x is 0, y is 0. Now 0 and 0 is x0 is here. What? Okay, not that. x0 is just along on top of the line. y0 is also on top of the line. So you see, the point you have is just on top of the line. You see, that is the x is equal to x, and the y is equal to what? The y is equal to x version. You do the same thing, 1 and 1. I think now you can see 1 and 1 is going to be here. You can use the same concept. 2 and 2 is going to be here. 3 and 3 is going to be here. And then where did we end? I think it was 4 and 4 is going to be there. It's just a matter of you carefully checking these points. Then you join these points. It's a straight line. So you take your ruler and then you join these points. You don't have to stop there. It's a line. It's telling you that this thing was going to continue like this. And then because I'm limited with drawing, but there it is, I managed to do that. You see, that's what you're having. Then you come here and label it to say this graph is y is equal to x. You need to tell us what you're sketching. So that is how you draw this graph of y is equal to x. Then after that, you are going to draw the next one on the same axis, y is minus x. You do the same thing here. You need to know the points. When x was minus 3, y is 3. So you come here and say when x was minus 3. So for example, x is minus 3. I'm looking like this, a line like that. That's x is minus 3 and y is positive 3. Then you're like, oh, there is my positive 3. Look, that is where the point meet. See that? So you mark that. So I'm using this just to show you that that's how easier the points can be. And then the other one, when x is negative 2, y is 2. You do the same thing when x is minus 2 to be like this, y is 2. There it is. So here is the point. See that? And this, let me take it off, and this, let me take it off. You see, when x is minus 1, y is 1. There it is. When x is 0, y is 0. It's on top there. Let's look at the positive. When x is 1, when x is 1, yes, 1, y is minus 1. Because I did 1 and 1. And x is 1, y is minus 1. Let's go to x is 1. There is x is 1, like this. And where is y? Y is minus 1, like this. You see that? There is the point. I hope these are making sense on you being in a position to sketch this. So when x is 2, y is minus 2. You can continue. When x is 3, y is minus 3. When x is 4, see, let me just do another one. When x is 4, you just do this as an example. Y is minus 4. You do that. Remember, I'm getting it from there. When x is 4, y is minus 4. So there is the meeting point here. That's how you mark that particular Cartesian plane. So what I want you to do is you take a graph paper and also practice this. Just grab a graph paper and then practice this with me, because you need to have a practice on how you plot these graphs. You see, so once this video is done, you take a graph paper and you attempt this graph of what? Of y is equal to x, and this one is y is equal to negative x. That's how these graphs are sketched. That is sketching and or plotting these graphs. Are you with me? So that is what I want you to start learning now, using the table method, coming with your values, the x and the y, and verifying them with the calculator, and then coming up with a graph like that. So the question, what was it saying? It said to us, sketch and compare the graphs of this. So when you talk about comparing, let me come back in. When you talk about comparing, look at this. This graph, it passes through that O. We call 0 the origin, you see. They all pass through the origin, but the other one is going the other direction. We say this graph, I'm going ahead of myself. We say this graph has a negative gradient. gradient. We'll talk about gradient. I won't remove these graphs. I'll leave them like this so that when we come to the other lessons, we'll be talking about gradient. And this one, which is slanting on the right hand side, you see, it's more like moving. If I'm saying you are moving this direction, it's more like you're moving from negative and then to positive, you see, to positive. But here is more like you're moving from positive, and then here you are now at negative. So the negative, hence the negative gradient. The one from negative positive, we call it the positive gradient graph. The positive gradient. We are here to talk about the concept of gradient. So these graphs, they are all straight lines looking similar, but their only difference is the gradient. That negative, you see, it made the graph change. Look, when we said minus x, look how the graph changed from the one of positive x. The other one was just x. Look where it was. The other one, the moment you put a negative, it also changed the what? The inclination, which is the gradient of the graph. So guys, I'm going to end the lesson here. In our next lesson, I will try to then do these other two graphs, which we need to check, whereby we look at that graph, we look at that graph, we look at that graph. The aim is to make sure that you know how to go about these graphs. We analyze them, I show you how you sketch them, and I show you the difference between each of these graphs. So you need to definitely get hold of the next video. Thank you.